Good morning. Today is October 2nd, 2020, and once again, there are plenty of open spaces for those who want to actually come into the classroom. Right now, there's only 3 people in front of me, so Ritvik can take attendance. Sam, what's your last name, Sam?
Becker.
Sam P?
Sam Becker.
B, Sam Becker.
Kenzie Morris.
Kenzie Morris and? Hannah L. Great. So I think there's like 11 open seats here. So come on in. Let me show you real quick what we're doing today. Share a screen. I'm under resources, and what we're doing is introduction to regressions. So let me open that up, lecture 9. And for data files, we need the very top one. And the top one is brooklinecondodata.xls. Let me open that one up also. So right now you should see intro to regression. And if you don't, somebody unmute yourself and give a quick yell. And real fast, 2 brief announcements. 1, problem set number 2 is due today at 6 o'clock. So please submit it. And the next big thing is Project Part A. Project Part A is where you, as part of a team, show me that you can do graphing, summary statistics, and tell an interesting story in a professional manner. And that's due October 13th, which is about 11 days from now. So far, 35% of the class has said, I want to be a team, and sent me who's on the team. But that leaves about 2/3 of the class unteamed. About halfway through today's lecture, we'll have a discussion question. I'll put people into breakout rooms, which gives you an opportunity to meet people again and go, oh yeah, maybe you should be on a team. But if not, sometime this weekend, I'll send out, for those of you who have not sent a team, that you're part of a team, I'll send out sort of a random group of assignments. So sometimes it's easier if you're matched up by yourself, but if you want to be randomly matched up, okay too. So I want to give a quick example to motivate why we're doing regression analysis. And then I want to talk about the case we're going to do, which is going to take us a number of days, and that's real estate, and trying to become very much like Zillow. So let's talk a quick example about regression. And one of the ways, good morning, what's your name?
Jacob.
Jacob. So Ritvik Jacob just showed up.
Sorry.
I think, no. We're trying to make sure we get everybody's attendance. All right, we're up to 4. I'm feeling better. All right, Friday morning. So one of the ways of becoming wealthy is to come up with a brilliant idea. And there's been lots of examples of brilliant ideas. Who would have thought making TikTok videos of people dancing around silly, right, would lead to a number of people becoming billionaires? I mean, I understand inventing things like electric cars or other things like that makes people really rich. But some of these small things have made people incredibly rich. A couple of other examples of ideas that have made people rich that are small. The person who invented the Rubik's Cube. I don't know if you've ever played with Rubik's Cubes, right? The guy did quite well with that. And when I was a teenager, somebody invented something called a pet rock. They went out, they found a whole bunch of rocks about this big. They painted them little colors, and they added little tags that said, hi, my name is this, and they sold them as rocks. You know, so you could, this is your pet. Hi, this is my pet rock. Basically, walk around on a beach, pick up a whole bunch of rocks, clean them up, stick a little tag with someone's name on it and a cute little saying, and they were selling for about $11 a piece. There was a group of people who did that, and they made a fortune selling rocks. So it's not always, it's sometimes coming up with great ideas, but it's not always. Sometimes what people do is they find mispriced items. There's a lot of TV shows, what's called Antiques Roadshow, where people find things in their basement or attic, and they're like, is this valuable? And oftentimes on that show, it's like, no, this is junk, no, this is junk, or you always thought it was valuable, but no, it's not. And then they bring something in and someone goes, you know, this is worth a fortune. The person goes, and then falls down on the floor, and they bring in someone to do CPR. Have you ever seen Antique Roadshow? No? Paul's pretty much the same thing. Where suddenly, hey, guess what? You're rich. There was a great article a couple of years ago in the Wall Street Journal. It talked about a man who was, I don't know, a baron or a duke or something like that, but the family had fallen on hard times. He owned this giant castle up in Scotland, but the castle was falling apart. The roof was leaking, the foundation needed fixing, and he was basically doing an Airbnb. And his thing is stay in a real authentic, like, Scottish castle with a real authentic Scottish nobleman, but he was basically flat broke. But in the basement, there were cigars, and whenever somebody who he really liked, he'd pull out a few cigars out of the basement. And one day, somebody from London stayed up who really understood cigars and said, man, do you know what you have here? And he goes, oh, good cigars my great-great-grandfather put down in the basement. He goes, these are worth a fortune. And they went down and they found a couple of unopened boxes of cigars from like 1875. And they auctioned off 2 boxes of these cigars, and the Duke, or Earl, or whatever he was, basically got a couple of $1 million for a few boxes of cigars that had sat in the basement. And it was enough money. And what did he do with the money? He paid someone to fix the roof, or not someone, but a whole group, because it was like a very large house. They paid someone to fix the foundation and did all the upkeep that had been deferred for like 100 years. Find something. So what we're going to talk about right now is wine, the price of vintage wine. And in particular, wine is very expensive. Now, there's cheap wine out there. You can go to Trader Joe's. Most of you are under 21, so you probably don't know this. Trader Joe's is very famous for selling something called $2 Chuck. It's actually $2.99 right now. So rounding, it should be $3 Chuck, but that's not very good for the marketing. So they call it $2 Chuck. You hold $2 Chuck for 50 years, it's just bad wine. It's cheap bad wine today, and it's cheap bad wine 50 years from now. But there are some wines that, as they age, become very, very expensive. In particular, some of the wines that age come from France, and in particular, they come from the Bordeaux region. So they're called fine Bordeaux, and some of these are worth a single bottle you could buy a car with. There's a great example here. I'm going to go to this website. Give me 1 second. And online, make sure that I show you the website, that you can actually see the website. Open up a new tab. So these are some of the most expensive wines. Let me do a sharing so you see the screen. This is called Wine Searcher. Wine Searcher is if you're really interested in expensive wines, you spend a lot of time here looking up the prices of things. So there's things like the Libre Pater, average price $4,200 for a single bottle. The Patras, $3,500. Lafite Rothschild is about $917 or so. And the one I want to highlight real quick is the Chateau Margaux for $729 on average per bottle. And then I'm going to actually show you that the prices vary widely for each bottle, but let me just tell you a really quick personal story. I have a good friend. He likes to drink wine. I brought a nice bottle of wine over. A nice bottle, i.e. not a $2 Chuck, but not a Margaux here at $729. We enjoyed a couple of bottles together, my wife and his wife and things like that. And then just before dessert, he said, you know, you really like wine. I said, oh, I really do. He says, I have a special bottle in the cellar that I've been looking for a reason to open. And I said, oh, okay. And he brought out Chateau Margaux 1967 bottle. And I said, woo, that is really an expensive bottle. Sure you want to open it for me? He goes, well, I didn't actually pay for it. I have 2 friends who were divorced, and they agreed on the house, they agreed on who got the dogs, they agreed on the cars, they agreed on everything except for the wine collection. They could not agree who got the wine collection. So I got the wine collection. So for me, it's basically a free bottle of wine. And he and I were both, I'll admit, on tape, a little tipsy. So he's like, yeah, let's open a nice bottle of wine and find out. So he brought the bottle up from the cellar. We pulled off, there's a little bit of a tin foil lead cork, lead wrapper on the top, and the cork was all black. When a cork is black, that usually means the bottle has rotted and there's mold everywhere. But when you're looking at a very expensive bottle of wine, I say, whoa, I've never had a bottle this expensive. Let's open it and taste it. So we opened it and tasted it, and the bottle had clearly gone off. But as, well, I'll say it clearly, as an idiot, I said, so what? I've never had an expensive bottle of wine, even if it's gone off, whatever. So I proceeded to drink most of the bottle of wine. My wife said, is that a good idea? And I was like, I've never had a very expensive bottle of wine before. Why not? Well, make a long story short, I got home about midnight. I threw up at 1 o'clock, 2 o'clock, 3 o'clock. I threw up every hour on the hour until about 9 in the morning. And then I laid in bed for the rest of the day going, oh. So what is the moral of the story? The moral of the story is just because something is expensive doesn't mean you should indulge in it. Let me repeat that. Just because something is expensive doesn't mean you should indulge in it. All right? And by the way, I did go to Wine Searcher about 2 days later, and the bottle that I thought was cost about $4,000, I was off by 1 year. The bottle that we opened was only about a $500 bottle of wine. So worse, I was misled by my own mind on exactly which year it was. Let me click real quickly on Chateau Margaux, and it'll bring up all the various years. You can go back to 1884. So real quick, I'm going to click on the most recent year, 2019. And somebody online, can you see?
Yes.
Yeah.
Great.
Yes.
So here's the 2019. And what you can see is right now a bottle of wine is, so the big number here, 2,714 is for 6 bottles, but right below it says 452. So the cheapest bottle of wine that Wine Searcher can find anywhere in the world is $452 for a bottle of wine that's 1 year old. All right, a little bit more expensive than $2 Chuck. But let's jump to, so remember that, 452. Let's jump to 2016. You want to impress somebody, but they can't remember exactly what year. The 2016 is only $75.73 for a bottle of wine. Same grapes, same acreage, slightly different growing season. It's 3 years older. Wait, is it older wine supposed to be better? 3 years older, and it is, well, I won't say affordable, but something a college professor like myself could go, oh, I think I could have, you know, I'm not going to drink it every day, but, you know, for a special occasion, maybe we could buy a $75 bottle of wine. No? Yes? Sort of makes sense? It's like somebody, you know, at their special day, they're graduating from college, could you spend $75 for a bottle of wine? It's within reason. Let's go 1 year earlier, 2015. And it's $1,000, $1,036 for the cheapest bottle of wine. What's the key point of me showing you these numbers? 1 year makes a huge difference. Growing seasons are dramatically different. So any questions online about that key idea? 1 year on wine makes a huge difference, whether it's cheap or really, really expensive. Okay? Let me stop sharing my screen and go back to the slideshow now that you understand a little bit about wine. And what's the idea about wine? You can make a fortune buying and selling wine, just like you can make a fortune buying and selling stocks, bonds, mutual funds, hedge funds, and things like that. It's just another investable asset. So the question is, can you predict which wine is going to be great? Why? Because people in Bordeaux sell wine futures. What is a wine future? I could right now buy the ability to buy the 2021 harvest. No one's tasted the 20, it hasn't even been planted yet, but I can buy on the future. I can say I want 50 cases of the 2021. And why do they do this? Because winemaking costs a lot of money up front. You have to pay your workers today, and you don't get to sell the wine for 3 or 4 years. So these high-end vintners, these high-end vineyards, sell wine in advance to get cash now, and they sell it for a fixed price, and you're making a bet that you're paying today something you're going to get 3 or 4 or even 5 years later from now, you're not going to know the quality of. Does that make sense? But that gives the vintners, the vineyards, cash up front so they can pay their workers, they can pay their taxes, they can buy fertilizer, they can do all these kind of things. So there's a man, I think Robert Parker just recently died. He was a lawyer who liked wine, and he invented this 0 to 100 point scale. I don't know if you've ever been to a wine shop and they have labels that says 92, you know, by, no, never mind. Anyways, You walk into wine stores and about 20% of all bottles have numbers between 0 and 100. And they really trump it. Oh, we are a 92, we're a 93, we're a 94. And it's just like getting an A, you know, close to URL 100 is perfection. He invented the scale. He became one of the most famous people in the world. And all he did up until his death was sip wine and give it numbers between 0 and 100, and then write a couple of sentences. Ori Ashenfelter, he's a Princeton economist, just like me, you know, except he wears a tie. I don't, all right? Just gives lectures all the time. And the question is, who should you trust about wine? One of the world's foremost experts on wine, or just another academic egghead? So what Ashenfelter figured out was that the weather really was the key factor for wine quality. The difference between a $75 bottle of wine and a $1,000 bottle of wine was all about the weather. And he estimated a regression using historical data to try and figure out weather and wine quality. And it's a very simple regression. And it was revolutionary because he was able to predict the price of a vintage 10 years into the future. Simple words, he could figure out which vintages are going to be really expensive in the future, and he could buy them today. When he came out with this regression, the regression was pretty straightforward. The quality number of the wine was equal to 12. So basically, Bordeaux, even if it had a terrible year, the numbers were 12, you know, 15. They didn't go down to 0. All right? Plus 0.012 times how much winter rain happened in centimeters, and there was a single weather forecasting station in the middle of all the vineyards that everyone knows. It's like called the Bordeaux weather station. I don't know how many of you are from Massachusetts, but the most famous weather station we have is on top of Blue Hill. Blue Hill is just outside of Boston, but when they quote Boston weather, they talk about the Blue Hill Observatory. So there's a weather station just on the edge of the town. All right, same kind of thing. In Bordeaux, there is a weather station that everybody knows about that gives the weather in the wine region. So it's how much rain showed up in the winter in centimeters times 0.012 minus 0.04 how much rain showed up during the harvest season, basically September, but it's slightly different in Bordeaux, but let's not get into the days they call the harvest season. Plus 0.06 times the average growing season temperature in Celsius. So all he did was he didn't taste any of the wine. He looked at rain in the winter, rain during the harvest, and average temperature during the summer. That was it, 3 small factors. And when he came out with the equation, he said that the 1990 wine would be the wine of the century. And everybody in the wine industry laughed. Robert Parker, the famous wine critic, said it was absurd. And Ashenfelter went out to France and he just bought a huge amount of 1990 wine, stuck it in his basement in Princeton, New Jersey. And 10 years later, what happened? It turned out to be the most expensive set of bottles around. Ashenfelter was sitting on a gold mine. Now, as a good economist, he is now sitting on a fortune in his basement. What did he do with it? Anybody online? What's your thoughts? What did he do with all this fancy wine in his basement?
Sold it.
Drank it.
He drank it. He did not sell it. He did not make a huge profit. Instead, he invited all his friends and any of his friends over, and they had a wild parties and lots of things, and that was like the mark. If you got invited to Ashenfelter's house and you opened up some of the 1990 wines, you had made it in academic circles, okay? So he did not take advantage of selling it off. He basically used it to improve his friendships in the world. And no, I was never invited to Ashenfelter's house. I only heard stories about it, okay? I only get invited to people's houses where they give me bad wine that poisons me. It's a joke, You can't say I'm smiling. Okay. So our goal is to build a model just like this, except instead of looking at wine, and since most of you are under 21, we're going to look at housing prices, which in some ways is just as absurd. You can't buy wine. You can't buy a house right now. I mean, how many of you are like, oh, I'm interested in buying a condo in Boston? So it's the same kind of, you know, it's really hard to find examples, of real life examples that undergraduates are like, oh, I actually do these kind of things. If you do happen to come up with something that's useful for undergraduates, let me know. As the course coordinator, I am always looking for a great example that lasts over multiple, class days, where we can say, oh, that really works. I don't know. Is there anything undergraduates buy and sell? Like 15 years ago, it would have been Pokemon cards, but no one does Pokemon cards when you're 18. That's like, what are you, a kid? You're lame. Buy and sell textbooks. I would say some of you do. Given I actually get the data on how many people read the QM222 textbook, about a third of the class hasn't opened it and it's free online. So I'm not, I think 5 years ago, that would have been a great example, but every year we go into the future, I think fewer and fewer students even touch the textbook, at least watching the data. So it was a good example. 1 2-finger pat on the back instead of a whole hand. Yeah, okay. Anybody else? Anybody online with any good ideas?
Shoes or like sneakers specifically?
Yeah, sneakers are a really good example. There's a lot of trading in sneakers, and the problem with the sneakers I have is that there's so many different brands and so many different sub areas, and they really hold it back. Like this sneaker was only made like 1,000 pairs of. Wine and housing prices are easy because there's millions of very similar things. Even some of these famous French vineyards, they make 500,000 bottles of wine, and that's a small run. But sneakers, it's like 500. It's like, oh, it's super rare. I'm really looking at something with lots of data. Does that make sense? So lots and lots of transactions. Great idea. Anybody else? Textbook has been lots of transactions in the past. Go ahead, somebody. I'm sorry for interrupting whoever you are.
Yeah, so I was gonna say you could do graph late night dining, like how many people order late night dining based on like how many tests are happening. So if like there's more tests, there might be more late night dining, and also use another point for like weather. If there's like if it's snowing, people.
Nobody goes for late night dining. Yeah.
The only thing with that is that I don't know how you'd quantify like snow in that, but I don't know. That's something that's interesting.
Well, we could quantify snow by how much snow falls at the local observatory. They actually release hour by hour. But the question is, how do we make money off of it? So I'm looking for something like wine you could make money off. You could see an arbitrage opportunity, buy low, sell high. Same thing for houses, make an arbitrage opportunity. But how do you make money off of dining?
What about diamonds and gold and those items?
Diamonds and gold are great. I completely agree. But the problem is I'm not sure a lot of students are buying diamonds. I think it has the same problem as condos in Boston or fine wine. It's just not something you commonly trade.
What about Bitcoin?
Bitcoin's great. And you say computers? Let me think about computers and Bitcoin. The question is, what are some of the fundamental factors behind Bitcoin? And I'm not sure anybody knows. But I will think about that on my way home today. Computers. Is there any market for used computers? There is? Oh, okay. All right, okay. Somebody else online said something?
Oh, I said like, how about stocks and like all that stuff? Because I know like some friends of mine, like they trade options and stuff like that.
All right, that would be interesting. All right, you've given me some things to think about on my walk home. And let me just say real quick, Ayush, shaved off your mustache? What happened?
I don't know. I got a lot of critiques from a few of my roommates, so I had to take it off.
All right. Well, come on in person. We miss you. Okay. So what we're going to do is we're going to look at real estate. And once again, I'm sorry that this is not super, matched up with exactly what you're going to do. And what we're going to do is we're going to look at one town, Brookline. I have all the data for Boston. As a matter of fact, I worked with the mayor's office, the city of Boston, in June and July, trying to come up with a model for real estate prices in the city of Boston. I spent probably 2 weeks working with the people downtown. But the problem with Boston data is that every neighborhood is dramatically different. So home prices in, say, the North End, which is the area with all the great Italian restaurants, are very, very different than, say, East Boston. Even though from East Boston, you can see the North End, right? Just a small separation of water, it's a totally different market. And it takes a lot of correction to handle all the neighborhood effects. And I don't want to get into Boston neighborhoods. So we're going to do one town. We're going to look at Brookline, Mass. And we're going to look at a whole bunch of different things in the data set. And what's the model used for? The model is used for something like Zillow. I don't know how many of you have been to Zillow, but basically you type in an address in Zillow, and there's a number of other competitors to Zillow, and it tells you exactly how much the house is worth, and it'll tell you how much the house was worth 6 months ago, a year ago, 5 years, and even 10 years ago. You can track the whole thing over time. And so what we're going to do is we're basically creating a model for Zillow. The only difference between Zillow and our model is that Zillow does homes all across the United States, and we're just doing it for one town. So all we have to do is expand the data and get bigger computers, and we've written Zillow, plus we need a fancy interface and accept ads and all that stuff. But we're doing the underlying model for Zillow. So we're going to start off by looking at a relationship between price and size. Is there a relationship between price and size? And before we do anything or even look at the graph here on the screen, I would say, do you think bigger houses sell for more money? Everybody in class is nodding. A few people I can see online are nodding yes. And some of you are nodding off. Okay, so let me stop sharing and open up the Excel file. And now that I've opened up the Excel file, let me share the screen. So this is under Resources Data File. This is called Brookline Condo Data. And the very first thing we need to do when we open up any Excel file is to explain what all the things are in simple words. All right, so I need somebody online to identify themselves and randomly shout out a number between 2 and 18.
I'm Kira, 11.
Hi, Kira. Did you say 11?
I did.
Okay, so Kira likes 11. 11. This condominium sold for $382,000. And by the way, these data are about 7 years old, if I remember right. So 7 years ago, this condo sold for $382,000. Its address is 1731 Beacon Street. So you can actually walk, for those of you on campus, you can walk and look at 1731, or for most of us, what we do, bring up Google Maps and type 1731 Beacon Street, look at Street View. See what it looks like. The unit was 947 square feet, about 1,000 square feet. 1,000 square feet. Looks a little smaller than the classroom we're in right now, which is room 322. Floor. So this is the number of floors in the building, and it's on the 6th floor. All right, so it's a 6th floor unit. The building is a high-rise, which means it probably has more than 6 floors. There are 2 elevators in the building. The condo had 4 rooms, of which 1 was a bedroom. Bathrooms are not counted in the room count. All right, so in Massachusetts real estate, bathrooms aren't part of the room count. So there was a full bath, 1 full bath, no half baths. What's the difference between a full bath and a half bath? A full bath has a full toilet, a half bath has a broken toilet, right? That's a joke. Anybody online with the difference between a full and a half bath?
A full has a shower and a half doesn't.
Right, full has a shower or a bathtub, some way of, washing yourself beside a sink, and a half bath usually just has a sink and a toilet. Great. And garage parking, it has 1 garage spot. And if we go up a couple of lines, this condo here had 2 parking spots. Let me say in Brookline, garage parking 2 just basically means it's a parking spot. It's not necessarily a full garage with a garage door. It could be, just a spot with a little bit of an overhang on it. All right. So garage is just consider it parking spot, not garage parking. Any questions about how to read this file? So what I'd love you to do is I'm going to send you off into breakout rooms for a minute or two. This is your opportunity to meet each other, say hello, and I'd like you to calculate A, the correlation between size and sales price, and then B, create a scatter plot between size and sales price. So there's 4 people here, you're going to make up 2 different groups, and then everybody online I'll put into a couple of small groups. We'll give you 4 or 5 minutes, so that gives you opportunity to meet and greet each other and see if you want to be in a team with each other.
Oh, Professor, could you repeat that again? What 2 correlations?
Size and sales price, size and sales price. So the question is, we think bigger places sell for more, but is that really true? Size and sales price. See you in 4 or 5 minutes. Okay, a whole bunch of chat messages. So let's see what's going on in the chat. Oh, look at all the Go East Boston, yes. Okay, so Rithvik, you gotta unmute yourself if there's something I'm supposed to pay attention to in chats.
No, yeah, I've been like looking through the chats,
Okay.
but like people have been like speaking up and saying them anyway.
All right, great. So tonight, what's your prediction? How much is LA gonna beat Miami by tonight?
I'm gonna easily have to say like 30, probably by 30.
30.
They're getting blown out. There's no way.
All right. I believe Miami is going to lose, but they're only going to lose by a little bit. They're going to make it sort of close.
You think they're gonna make it close?
For a little bit of the game.
Yeah, for a little bit. I feel like then like towards the end, it's really going to pick up, and the Lakers are really going to dominate.
We shall find out at 9:30 is the game? 9?
Yeah.
We'll find out at 9. Well, we'll probably find out at 10:30. 9's a little. I don't think anything's really happening at 9 o'clock. So, you don't have to work in teams. I'm just giving you sort of the opportunity. It's easy enough to do this problem yourself too. But part of the reason is not to see my charming face. So most towns, this is public information. So if you go to the townbrookline.gov, that's not exactly the URL. There's tax assessor office, and they have every 6 months the whole file. So this is not the whole file. This is just the condo data. So the single family homes are not here, just to make it a little easier. But you can do the same thing. The City of Boston's data file is so big that if you go to City of Boston Assessor, they say, we're willing to send you a DVD because it's so huge. Or you could use our FTP site, but we don't encourage you to use the FTP site. So most of this is public data, and pretty much every tax assessor's office has some way of pulling it down. And what Zillow did, and it's pretty amazing, is they actually have a whole team that goes like, every month to a tax assessor's office and, pings and says, hey, we have the latest tax assessor data. And some some cities and towns say, we reevaluate every 5 years. We don't have anything new. But there are others that do it on a continuous basis. So they're pulling it in, and Zillow is constantly updating their model. Plus, Zillow goes to all the courts. Whenever a real estate transaction happens and houses pass hands, they go to the courts and record that. So even though the tax assessment hasn't changed, the actual transaction value has changed. The downside of looking at sorry, I'm just blabbing here. The downside of using court data is that sometimes some transactions are quasi-illegal. What do I mean by quasi-illegal? You and I want to avoid taxes, or I want to avoid taxes, let's say, And by the way, for those listening on tape, I'm not suggesting this should be done. I'm just saying what happens to be done. And what happens is I charge you like $100,000 for a house that's worth $1 million. And what you give me is a briefcase full of $900,000 of cash, right? So the house transaction is recorded as $100,000. I grew up in a house in Medford, near Tufts University, and I actually was part of a project that had to research all the house prices in Medford before Zillow came out. This is a long time ago. And my house back like 150 years ago was sold for $1 and consideration. What was the consideration? It was $1 official transaction plus we have no idea, but there was some cash, other transactions that happened that was just called consideration. So that's where I found it out, that my house was changed hands for $1. And it was like all the other houses around it were going for much higher prices than this house. And there also is sometimes transactions, say somebody dies. I hope your parents never die, but your parents could die and then give you the house. So that changes over in court records, and that would mess up the Zillow model. So Zillow has to go through and try and figure out all the real transactions and then get rid of all the, oh, it's a gift, I gave it to you, right? Or I'm paying cash under the table. So it's not as simple. The regressions are simple. Gathering the data and making sure the data are real are part of the hard parts. All right, so it's 10:47. We have 13 minutes left. We've closed all the breakout rooms. And did anyone, I'm going to ask for one online volunteer for the correlation. And then I'm going to ask, when we looked at the scatter plots, we looked at a couple of different things. We looked at one was the slope. Two, we looked at whether it was a strong or weak relationship. Three, we looked at with any outliers. What was the fourth point? What was the fourth point we looked at?
Direction, form, and outliers.
Right, direction, form, strength, and outliers. Thank you. So maybe you could do direction. Okay, 7 seconds. 6, 5, 4, 3, 2, 1. Too fast. Okay. Everyone should be back. Could somebody online say what the correlation was?
0.865.
0.865. Is that what most of you got? Great. That was what I did. When you do the scatter plot, we're looking for, help me out, Hannah, direction, form, strength, and outliers. So, Hannah, why don't you do direction? It's upward sloping, so it is a positive direction. Great. Strength?
Pretty strong.
Pretty strong. Okay. Somebody else for the other two? Any voice from the heavens? Remind us, Hannah, what the other two were?
Outliers and form.
Outliers and form. Form was linear versus curved. Outliers means something way over. Go ahead.
For form, I would say linear.
Okay, so we have one vote for linear. Filippo, you want to give outliers?
I think there was one at like 2.5 million. That
Okay,
was,
so really one, but it wasn't total wild, right? It wasn't like
no, it
25
wasn't
million.
super wild, but that was just maybe the only one, I would say.
All right, I would completely agree with that. So I've stopped sharing. Let me bring up PowerPoint again. Share screen PowerPoint. And there was one outlier, it was sort of way up here, or maybe there was also one outlier here, but I would say we really don't have to worry too much about outliers. We don't have to strip it out. As I was telling you this about 20 minutes ago that I was working with the city of Boston, and in particular, the city of Boston data had one outlier that was really, really hard. It was one place that sold for $100 million in some neighborhood. I don't remember what it was, maybe Mattapan or something like that. And I was like, what? And we actually had a meeting over what should we do with this $100 million sale. And the question is, do we add it? Do we subtract it? It really made a big difference to the whole model, that one transaction. So outliers can mess up your model sometimes. Okay. So what we're going to do right now, and we have 10 minutes left, is we're going to actually create a regression, a simple regression. Our goal is to do a regression with one left-hand side variable and lots of right-hand, lots of explanatory variables. But first, let's just do a single explanatory variable, and then we'll build up the model. Because I believe in real estate, it's not just about size. There's a lot of other factors going on and what makes a house expensive versus cheap. I've been to some giant houses that I wouldn't pay very much money for. I've also been to some giant houses that were like, whoa, there's no way I could ever afford this in my lifetime. So it's not just size, but let's try size in the beginning. And what we're going to do is we're going to do predicted price. I'm highlighting it on the screen. Predicted price equals some constant plus some coefficient times size. And then we're going to talk about what those coefficients mean. So how do we do the regression and what's the results that hopefully we're going to get? There it is in slightly bigger font. Price equals some constant plus B1 times size. And the results we're going to get, I think on the next slide it's written even better. There it is. Price is equal to this number, 12934 plus 407.5 times size. That's what we should get. And then we'll come back and we'll talk about what this means. So let me stop sharing. Let me share Excel. How do we do a regression? Step number one, we pick data. And when we pick data, hopefully over here on the right-hand side, we see data analysis, toolpath. If it's not there, we have to go to options and add it in. So we go to options, add-ins, and then down the bottom, we pick Go, select the analysis toolpath, click OK. And now data analysis shows up here. So if I pick data, there's data analysis over here on the right side. Under data analysis, we're looking for regression. Regression begins with the letter R, so we click on regression. Everybody with me so far? Click OK. The Y range. Y is the left-hand side or dependent variable. Y range is going to be sale price, so it's going to be A1 down to A1086. A1 through A1086. The X range, the independent variable, is going to be size, and that's going to be D1 down to D1086. So we have A1 colon A1086, D1 colon D1086. We have labels in the top row. So I click labels, and that says the top row is things like the word size, price, number of garage spots. Constant is 0. Repeat after me, all of you together. Never pick constant and 0 unless I know what I'm doing. Never pick constant and 0 unless I know what I'm doing. Okay? Right now we don't know what we're doing, so we're not going to pick constant and 0. We pick OK. We get a whole bunch of numbers. The key numbers are here. $12,934 and 407.5. If you're having any trouble, in about 6 minutes the class ends, and I will be happy to stay online and help you. Maybe Rithvik will also stay a couple of minutes after class and help people if he's able. The left-hand side variable, the Y variable, the dependent variable, was price. Price means it's in dollars. Whatever the format, whatever the value of the left-hand side variable is, the coefficients take the same formatting. Because it's price, I make these coefficients in yellow money. Once again, do we need 12 cents in the coefficient in B17? Do we care about $12,934.12? No. So get rid of the cents. Just not important. What do these things say? It says price of Brookline condos is if the size of the condo is 0, what kind of condo or house would have 0 size? If you were doing a real estate transaction and buying something with no size. It's a little weird, but think about it. Hannah, go for it. Land. Exactly, land. So the typical condo in Brookline in this year, the land value is made up of 2 parts. Land price for average condo was about $13,000. Notice I'm rounding, and people go, oh, I can remember $13,000. If I say it's 12,934, but you people are like, what? And you forget about it within 5 seconds. So it's about, land price was about $3,000, and then for every additional square foot of space, the price goes up by about $400. So if a condo is 10 square feet bigger than another pretty close to identical condo, an additional 10 square feet means that other condo would cost $4,000 more. 100 square feet, $40,000 more. So if you've ever heard someone talks about, oh, price per square foot, what's the price per square foot in Brookline in these data? It's $400 a square foot. Make sense? Pat yourselves on the back. You've just done your first regression. Nice job. So what we'd like to do right now in our last 3 or 4 minutes is make an estimate. What if that very first condo was 1,000 square feet, the one that we looked at on line 11? What do we think the expected price of that condo should be? And it's pretty straightforward. Go ahead, Rishna. Rishant.
Professor, is it $413,000 because 400 is the 1,000?
I would say we can actually precisely measure it. If it's 1,000 square foot, what we can say is it's equal to B17 plus B18 times whatever the size is, 1,000. I know it was like 984, but let's just use 1,000 because I can remember that. So the price, and do we need 46 cents? Once again, no. So that 1,000 square foot condo should cost about $420,000. A little bit more than coming here to Boston University. About 1.5 times. So you have a choice. Go to BU or buy a condo.
For this, what we can do is we can put cost and like BU housing.
We could. Well, that's a good idea. Make it relatable to students. And what you actually find out is that short-term housing in Boston and short-term rental spaces in Boston are really, really expensive compared to long-term. I have 30 seconds left. Some of the most expensive office space in Boston is in the incubator spaces. So you're like renting a desk. I don't know how many of you have heard of incubator spaces where you rent a desk for like a week or 2 weeks at a time. And you're like, oh, it's only $200. And they're like, yes, but we're only giving you about 5 square feet, okay? And $200 monthly on 5 square feet, you're like, wow, this is amazing compared to real-time office rents. Because they're giving you almost no space, actually. And they're pre-COVID, they were packing everyone like side by side, giving you basically a library carrel. All right, it's 11 o'clock. Have a wonderful weekend. Please try and form some teams and send me some emails. If not, I will send you an email identifying what team you're on. And if there's any questions, I'm happy to stay around and chat. Stay healthy.
Thank you.
Professor?
Go for it.
So when we were doing the correlation, when do we use the equals coral, like the equation, and create a correlation matrix? Because I was trying to create a correlation matrix and the computer was not happy with me.
So why would the computer not be happy with your correlation matrix? because you have a whole bunch of columns here with words in them.
But I
Right.
didn't use those. I just tried to use the A column and the D column.
So a correlation matrix means everything from the A to the D column. With a correlation matrix, there's no way of picking just individual columns. It says in the correlation matrix, it's everything from A to D, which is why you're picking up
Okay.
things like C, which have Pleasant Street, Houston Street, Washington Street, and so on.
Yeah, because I was painstakingly going just A and D, and it was just very
Yeah.
not happy.
Yeah.
All right, thank
So if you're
you.
doing painstakingly, you have to use equal correl.
All right, cool. Thank you so much. Have a nice day.
You too. Thank you all for coming in. Please keep on coming in.
Have a good one.
Wait, could I just move that row if I'm making a correlation matrix?
You could certainly do that. What I also sometimes suggest, Serenity, is you make a copy of the data and then you delete all the columns with words in it. So you have a copy in the Excel spreadsheet, you delete it, you make the correlation matrix, and it happens real fast.
Do you mean like open up a new one or just copy it into a different row?
So you could just copy the whole file, or here's what I would do. Hang on, let me show you my screen.
I can see it, yeah.
Okay, so what I would do is I pick move or copy. I create a copy of the data sheet. I call it temporary, TMP, just so I know what the heck I'm doing. I delete the words, delete, and now I just run the correlation matrix on everything.
Do you by any chance know how to do that on Mac? Because when I right click on the data, it doesn't give me a move or a copy. Oh, just kidding, it does. Okay, I got it. And then I had one more question.
I'm so glad I could answer those questions so quickly. You don't have to finish your questions that I already answered.
How did you get 420,000 for that last part that we were doing before class ended?
All right. How did I get 420,000? What I said is, this is the intercept, which is the base. This is just the land. And then this is $407 per square feet. So my formula is right here. It's the base, the intercept, 12,934. That's the B17 part right here. Plus, it's whatever the 407 coefficient is. It's the square footage coefficient times the size. Because I said the house we're looking at on row 11 was 1,000 square feet.
Oh, there we go. Okay.
Which is only because I think it was Kira who picked the row 11. It could have been a different row and a different number, a different size.
Yeah. Okay. Thank you.
Okay, have a great weekend.
Yeah, you too. Bye.